Hello folks, and welcome back to another lesson. Today we're going to talk about solving systems algebraically. So last time we talked about how to solve them graphically. Now we're going to look at some of the ways algebra can do this. And to start off, we want to make sure that we understand where graphing could fail us, or what some of the issues are, so why we would need to use algebraic equations. To do that, let's try to graph these and figure out where they would meet. We start out with y is equal to 2/3 x plus 1, so we're going to go up to 1. Going to go up 2 over 3, up 2 over 3, and so on over 3, and we draw our line. For the other one, y is equal to minus 2x plus 4, we go up to plus 4. We go down 2 over 1, down 2 over 1, and so on. So our question is, what's our solution? We know our solution is somewhere in here, but it's hard to say what our precise solution is because it doesn't cross over one of our lines. So what are our problems with solving by graphing? Well, one is it's hard to do when the intercept is annoying. The intersection is bad. And what about if this was all the way out at 60 on x and 35 on y? It's hard to do for large values. This is where it makes more sense to do things algebraically. Now we're going to cover two ways to do this. The first is substitution. And all substitution is substituting one equation into the other for a variable. Now how does this work? Well, we have a 5-step process here for solving by substitution. The first step is going to be making sure that one equation is equal for x or y. So making sure we have one variable on one side. Let's phrase that a little bit better. Let's say, let's make sure x equals something or y equals something. In this case, do we have x or y equal to something? We do. In this first equation, we have y is equal to 3x plus 1. Our next step is going to be substitute that in for y in the other equation. It's very important that we substitute this in for the other equation. So we're going to take y here, and we're going to substitute in this mess in for y in our other equation. Meaning that when we do this, we'll get minus 5x plus, instead of y, what is y equal to? It's equal to 3x plus 1. So we're going to throw parentheses around. We're going to say 3x plus 1, because y is the same thing, and that's going to be equal to minus 5. Step 3 is going to be solve. So 3 is going to be solve. So we're going to solve for this. We get minus 5x plus 3x. This gives us minus 2x plus 1 is equal to minus 5. To solve for that, we're going to subtract 1. We get minus 2x is equal to minus 6, or that tells us x is equal to 3. So we've solved for x. Step 4 is going to be substitute that value into either equation and solve. And then we're going to solve. So we can easily solve for y by plugging it back into our first equation. We don't have to do anything except for complete our calculations. So let's do that. We get y is equal to 3 times 3 plus 1, or y is going to be equal to 10. So step 5 is going to be solve. And when we're done, we're going to write our solutions as an ordered pair. So our ordered pair is x is equal to 3, y is equal to 10. How do we check our answer? Well, we substitute those values back in and make sure the answers make sense in both equations. We need to sub it back into both equations. Because again, like when we were graphing, it needs to be true for both equations. Let's do one more of those for practice, and then I'll let you all try one on your own. So we're going to go ahead and try this one. First step is to make sure we have x equals or y equals. We have y equals over here, so we're good. Step 2, going to substitute all of this in for y in the other equation. So we get x plus 4 times, and let's throw parentheses around this. Throw parentheses around every time you're doing this, every time you're substituting. So we get 4 times 5x plus 13 is equal to 10. And this is why we threw parentheses around, because now we see we have to distribute the 4 in. We can't just multiply it by 5, we have parentheses, and it needs to go to both things. This will leave us with x plus 20x plus is 13 times 4. It's going to be 52 is equal to 10. Which we're going to solve for, we get 21x on one side. When we subtract the 52, we get minus 42. And we're left with x is equal to minus 2. Great, now we're going to substitute that in for x in one of these equations. Looks like the first equation will be easy to solve, so let's substitute it in there. We're going to get y is equal to 5 times minus 2 plus 13, or y is going to be equal to minus 10 plus 13, or 3. Meaning our answer is going to be minus 2, 3. Right, what about this next one? What is our solution as an ordered pair going to be? Well, let's work our way through it. We're going to substitute in x minus 7 for y. So we get 2x minus parentheses y, or y is going to be x minus 7 is equal to 11. We're going to distribute the minus in. We get 2x minus x plus 7 is equal to 11, or we'll get x is equal to 4. What do we do when we get this? We substitute that back into one of the other equations. We can substitute it back into the one on the right, because that'll make our life simpler, and we'll get y is equal to 4 minus 7, or this will be equal to minus 3. So our answer will be 4 minus 3. Now how do you check to make sure that's right? You substitute in these values for x and y into both equations and make sure it's true. So what are the things we need to remember? The first one, we want to sub into the other equation. When you substitute it back into your first equation, you'll just get a mess. So sub into other equation. And step 2, which we've been doing because we're throwing parentheses around, is distribute. So we got to make sure to distribute. Okay. That's how we do graphing or solving by substitution. Let's go ahead and try a slightly more difficult one. This one doesn't come out as nice, so we're going to have to do a little bit more work on this. Step 1, substitute in 5x for y into the second equation. So we're going to get 2x plus y, so parentheses 5x, is equal to 10. Or that becomes 7x is equal to 10. Oh no, what do we do here? Well, we're going to divide, and we're just going to have to deal with the fraction. So we're going to divide by 7, and we're going to deal with this fraction of x being equal to 10 over 7. It's not going to be nice though. With x being 10 over 7, we know y is going to be equal to 5 times 10 over 7. How do we multiply a number to a fraction? We set it over 1, so now we just multiply our tops and bottoms together. Get this will be 50 over 7. Meaning our solution for this, like one of the ones we might not want to do while graphing, is something ugly. It's 10 over 7 and 50 over 7. Now how do we know that this is true? We can substitute these back into both and make sure they work. Okay. Now, when we were graphing, we had 3 different possible types of solutions. What were those? When we were solving, we found out we could have 1 solution, we could have 0 solutions or no solutions, and we found out we could have infinitely many solutions. So infinitely many solutions. Let's take a look at how those last 2 will work out when we're solving by graphing. When we're solving by graphing, or substitution, why do I keep saying graphing? When we're solving by substitution, we're going to substitute this in for y. So this becomes minus 6x plus 2 times 3x plus 5 is going to be equal to 10. We distribute that in, we get minus 6x plus 6x plus 10 is equal to 10. If we have a 6x and a minus 6x, that leaves us with 0x, or nothing. So all we're left with is 10 is equal to 10. Well, yes, that's true, but what does that tell us about our x and our y? This tells us that no matter what we do, no matter what we plug in for x and y, these will always be correct. So this is an infinitely many solutions. If you get something at the end where it's always going to be true, you have infinitely many solutions. What about no solutions? Well, if we substitute in for x minus 2y plus 10, let's see where that gets us. We get 2 parentheses minus 2y plus 10 plus 4y is equal to 30. We're going to distribute the 2 into both sides. We get minus 4y plus 20 plus 4y is equal to 30. Our 4y's are going to cancel. So all we're going to be left with is 20 is equal to 30. And that's very much not true. So if you're left with an equation that is false, you're going to have no solutions. Where it's one number is equal to another, and they're not, that's no solutions. If it's true, like 10 is equal to 10 or 0 is equal to 0, that means we have infinitely many solutions. Right. That's it for graphing. We have our second option here. Our second way of solving is by elimination. And all elimination means is we are going to eliminate one of the variables from the equations. Sort of like how in substituting, we got rid of a variable by substituting something in. This time we're going to eliminate. What are our steps for that? Our first step is we want to make sure our coefficients for a variable are equal and opposite. So first step is make sure your coefficients are equal and opposite. Why is that important? We'll see in the next step. But for this, we have a 2 and we have a 6. Those aren't equal and opposite, but we have a 5 and we have a minus 5. So those are equal and opposite. Here's why that's so important. We want to add the 2 equations together and solve. So we're going to add the equations together, then we're going to solve. So in this case, we're going to add. And how are we going to add? Just straight down the row. So 2x plus 6x will give us 8x. 5y plus minus 5y, 5 minus 5 will give us plus 0y, or plus 0, is going to be equal to 17 plus minus 9, or 17 minus 9 will give us 8. From there, we're left with no y, so this is 8x is equal to 8, or x is equal to 1. So what did we do? We just added straight down the rows. We added our x's together, add our y's together, add our constants together. So it's also important to make sure that you have everything in the same format. Okay. Last 2 steps are the same as previously. We're going to substitute x is equal to 1 into the equation and then solve again. So we're going to substitute our answer in. Into either equation Use whichever makes your life simpler. And then step 4 is going to be solve. So again, we're just going to take x is equal to 1, put it into one of these. I'm going to go with the top one just because I like smaller numbers. We get 2 times 1 plus 5y is equal to 17. Or 2, if we subtract that over, we'll get 5y is equal to 15. Or y is equal to 3. Meaning that our answer for this is 1, 3. Again, how do we check this? We substitute that in for both equations and make sure it comes out correct. Now, elimination is definitely the harder of the two, so we're going to do some more work with it. I'm going to do another practice problem. Actually, why don't you guys go ahead and do practice problem 1, then we'll do 2 together. So what is our solution going to be for the first practice problem? How are we going to do this? Well, we need to make sure our coefficients are equal and opposite. And we have a minus 6y and we have a plus 6y. So we're all good to go. Next thing, we're going to add across the rows. So 5x plus 3x will give us 8x. 6y minus 6y will leave us with nothing, so we'll leave nothing. And minus 32 plus 48 will give us 16. So we're left with 8x is equal to 16, or x is equal to 2. From here, we substitute that back in. Now the top equation has a minus in it, and that seems like a pain to deal with, so I'm going to substitute this into the bottom equation. We get 3 times 2 plus 6y is equal to 48. 3 times 2 is going to be 6, so we can subtract that over, and we're left with 6y is equal to 42. Right? This becomes 6, and we can subtract 6 over. 6y is equal to 42 tells us y is going to be equal to 7. Is that right? Let's put it into our calculators, make sure that this is correct. That is 7, meaning our answer is going to be 2, 7. What about for this next one? For this next one, we don't have coefficients that are equal and opposite. So we're going to need to make them equal and opposite. And how are we going to do that? We're going to multiply an entire equation by whatever we need to make it equal and opposite. So for example, looking at this, we have a positive 3 and we have a positive 3. That will almost work, but it seems like that's going to be, we don't have those equal and opposite. So instead, we're going to multiply one of the equations, and I'm going to multiply the top one by a minus 1. So we're going to distribute a minus 1 into all parts of the equation. And let's rewrite this over to the side here. What are we left with? Well, we're going to flip the sign. So we get minus 3x minus 3y is equal to positive 9. And the second equation stays the same. So it's 3x minus 4y is equal to 5. From here, we do have coefficients that are equal and opposite. We have a minus 3 and we have a plus 3, meaning we can just add these together. Plus and minus, those will cancel out. We're left with 0x minus 3x, or minus 3y minus 4y is going to give us minus 7y. And that's going to be equal to 14. When we divide both sides by minus 7, we'll see that y is equal to minus 2. From here, all we do is substitute that back into one of the equations. Looks like for this one, the minus in the negative 4 and the minus 2 will cancel out. So I'm going to sub it into the bottom equation here. It'll be the same though if you substitute it into the top. You get minus 3x minus 4 times minus 2 is equal to 5. Negative 4 times negative 2 is just going to be 8. So we can subtract an 8 from both sides to get 3x is equal to minus 3, or x is equal to minus 1. Meaning that our answer is going to be minus 1, minus 2. Now the things you have to be extra careful on. Make sure these are equal and opposite. We need our coefficients to be equal and opposite. Now I'm not going to lie. I'm going to tell you something here. You can subtract these equations. You can do it that way if you want. However, I find it leads to more errors. That's why I'm only telling you to add. Just make sure your coefficients are equal and opposite, and that way when you add through, you're not having to keep track of too many negatives. So we want to make sure that these are equal and opposite. And the other thing we want to be careful of is we want to make sure we eliminate a variable. Variable. Because if we don't, then we can no longer solve. This whole method is reliant on getting one variable by itself so we can solve. So these are the two things you need to look out for. All right, what about this next equation? What will our solution be? Well, I'll give you a hint. Probably the easiest way to go about this, right? We have opposite signs here, but we can't multiply 5 by 3 or 3 by 5 or anything. So if we look to minus 2 and 6, if we multiply this top equation by 3, we should be able to solve this. So what's our solution going to be? For this one, when we multiply by 3, we're going to get minus 15x minus 6y is equal to 18. And our bottom equation will stay the same. So it's 3x plus 6y is equal to 6. We add these together, we get minus 15 plus 3, or that's going to be minus 12x, is equal to 18 plus 6 is going to be 24, or x is going to be equal to minus 2. Okay, from here, we just substitute that back in. I'm going to go with the bottom one for no particular reason here. So we're going to get 3 times minus 2 plus 6y is equal to 6. Or minus 6 plus 6y is equal to 6, which we can simplify to 6y is equal to 12, or y is equal to 2. So those would be our answers, minus 2 and positive 2. This next one is trickier because we're going to need to multiply both equations to get them equal and opposite. Now I see that we have a plus and a minus on y, so I'm going to try to work with y here. We need to get 3 and 4 to equal each other. How are we going to do that? We need the greatest common multiple. Least common multiple, greatest common divisor. I flipped those. Anyways, we need something that we can multiply these both to be. And one way we can do this is just multiplying by the opposite coefficients. So multiply by 3 on the bottom and multiply by 4 on the top. When we multiply by 3 and 4, we'll make sure these come out to be the same. So this would then become 20x plus 12y is equal to 6 times 4 is going to give us 24. And then we have 2 times 3 will give us 6x, minus 3 times 4 will give us minus 12y is equal to 15. Or when we add these together, we'll get 26x is equal to, what will this be? 39. From here, we're going to divide this. It'll come out to be some ugly fraction, but we can just use the math frac button to determine what that's going to be, or to simplify it. Looks like that's going to come out to be x is equal to 3/2, or 1.5. From here, we're still going to multiply or substitute this back in. So let's substitute that back into this bottom one. That way we don't have to deal with a fraction anymore. We get 2 times 1.5, or that's going to be 3, minus 4y is equal to 5. So 3, we subtract that, we're going to get minus 4y is equal to 2, or y is going to be equal to negative 2 over 4, or 1/2. Meaning our solution is going to be 3/2, 1/2. Okay. Now what about infinitely many solutions? And no solutions. For these, it's going to look the same as with graphing, or with substitution, but let's go through these quickly. Going to multiply the bottom by a minus 2 to get our y's together. So we're going to get 6x plus 2y is equal to 10, and minus 6x minus 2y is equal to minus 24. When we go to add these together, we're going to run into an issue. 6x minus 6x will give us 0x, and 2y minus 2y is going to give us 0y, is equal to negative 14. Now, is 0 equal to negative 14? It's not. Again, we're left with an equation that will always be false when we have no solutions. Same thing will be true for infinitely many solutions, where we're going to again multiply by minus 2 on the bottom. We're going to get 6x plus 2y is equal to 10, and we're going to get minus 6x minus 2y is equal to minus 10. When we add these all together, we'll have 0x plus 0y is equal to 10 minus 10 will give us 0. And so this one, we're left with something true. 0 is equal to 0. So when you're solving using elimination, if you get a true value still, if you get something that's correct all the time, it's infinitely many solutions. If it's wrong all the time, it's no solutions. That's all we have for this lesson. So go ahead and get working on the homework.